Perpetuity due with semi-annual payments consists of two level payments of 300, followed by a series of increasing payments. Beginning with the third payment, each payment is 200 larger than the preceding. At an annual effective I, the present value is 475,000. Calculate I. So it's a perpetuity due, and they tell us the first two payments are 300. So for perpetuity due, the first payment should happen at time 0. So we have 300 at time 0, and then the second one is also 300 at time 1. And then they said that starting from the third payment, each payment is 200 more than the previous. So this one would be 200 more than the previous, so 500. And at time 2, and then fourth payment of 700 is time 3, and so on. So this first payment is not a part of the perpetuity, arithmetic perpetuity. It is a part of the perpetuity, but not a part of the arithmetic part of it, because in arithmetic we have a common difference. So this one just is the same as the second one. However, if you see from second, third, fourth, and so on, you see that that forms an arithmetic perpetuity with P is equal to 300 and Q is equal to 200. Remember, Q is the common difference. So let the semi-annual effective rate be J. And now the present value can be found. We want to apply the perpetuity formula, but since we said that this 300 first payment is spoiling the sequence, so we deal with it separately. So we can say that overall present value is the present value of this first one, which is 300, because it is sitting at time 0, plus the present value of all the remaining ones. And as we said, all the remaining ones form an arithmetic perpetuity. So formula for arithmetic perpetuity is present value is P over J plus Q over J square, where J is the effective interest rate over the period. And we are told that the present value is 475,000. So that'd be 300 plus 300 over J plus 200 over J square, because P is 200, P is 300 and Q is 200 in this part, starting from payment 2 onwards. Now let x is equal to 1 over j, so then that becomes a nice quadratic equation. 475,000 equals 300x. So we can subtract the 300 from 475,000. So we get 474,700. And then this part is 300x, because we are letting 1 over j equals x, and this one would be 200x squared. And we can divide everything by 100, so we get 2x squared plus 3x, and now this can be moved on the other side. It becomes negative, so negative 4747. And once we apply the quadratic formula, we get x is equal to 47.97. We are ignoring the negative value of x because x was 1 over the interest rate, and that cannot be negative. So x was 1 over j. 1 over j is equal to 47.974. J comes out to be 0.020845. And if I is the annual effective rate, then 1 plus I is equal to 1 plus j squared, because j is the semi-annual effective rate. Remember, the usual formula is 1 plus I superscript m over m, and m is 2 for semi-annual, so I 2 by 2, and j is the effective rate, which is I 2 by 2. So 1 plus I is equal to 1 plus the value of j, and we have whole square. I comes out to be 4.21%. That is choice E.